Chapter 5, Section 2, Common Factors, Apprentice. Though we are going to be talking about common factors, pretty much always we're actually going to be looking for what's known as the greatest common factor, or the GCF. And you definitely would have worked with greatest common factor before, but a little review doesn't hurt. So let's get right to it. Part A, we have three numbers, and what I want to find is the greatest common factor between these three numbers. Okay, remember, a factor is a divisor of a number. So for 12, I'm just going to make a list of all of the factors, prime and composite. I'm going to ignore 1 because 1 is neither prime or composite. So we have 2, 3, 4, 6, and 12. Okay? Those are all of the factors of 12. 16 is divisible by 2, 4, 8, and of course itself. 40, that has quite a few actually. 2, it's not divisible by 3, but it's divisible by 4. That's 4 times 10. Also 5. Okay. And then we get to pair them up. So it's 10 and 20 and 40. Okay. So all of those are all the factors of 40, and we want the greatest common factor between all three. So just look for the number on this list that's the biggest, that is shared by all of them. And I believe that is 4. Okay, so therefore the GCF is 4. Let's do another one. 12, 21, and 36. Okay, well, I'll just list the factors of 12 again. I know what those are from before. Okay, 21, that doesn't have very many because I know 21 is the product of two primes. So it's 3, 7, and 21. 36, now that I believe has quite a few. It's divisible by 2, 3, 4, 6, 9, whoops, 12, 18, and 36. Okay, and the biggest one that they all share, I think that's pretty clear, is 3. So therefore the GCF is 3. Part C, x cubed, x squared, and x to the fourth. This may look kind of scary, but in reality, if you're finding common factors when variables are involved, it's actually a lot easier than numbers specifically. Okay. And you'll see why in just a second. So x cubed, what are all the factors of x cubed? Well, remember, x cubed is just x times x times x. So x is a factor, obviously. X squared is a factor. And so is x cubed. Okay, that's pretty easy. X squared, well, x is a factor, and x squared is a factor. X to the fourth, well, x is a factor, x squared is a factor, x cubed is a factor, and so is x to the fourth. So, what is the largest one that they all have in common? X squared. And it actually turns out to be, well, the variable that has the, it's the monomial with the smallest exponent. Gives you the GCF. All right. All right. Now we're mixing up variables. We have x's and y's. And I'm just going to list all of the factors, but keeping the variables separate. So x cubed, of course, x is a factor, x squared is a factor, and x cubed is a factor, and y is a factor. Next one, x squared, y, and y squared. Okay. I could actually write more pairing the x's and y's together, but I'm just going to keep them separate. And so this is x squared, y cubed. So that's divisible by y. It's divisible by y squared. and of course it's divisible by y cubed. Right? So let's just find the GCF for all the x's. Okay? It's just the part that has the smallest exponent. Whoops, I'll keep that in red here. Because this is the largest factor containing the variable x that all three of these monomials share. And for y, well, the biggest one they all share, well, is this one. Okay. So therefore, the GCF is x squared y. Okay. Because all three of these are divisible by x squared y. All right, so part E, now we're just mixing up numbers with variables, so that's okay. Let's just do the numbers first. So 15, the factors of 15 are 3, 5, and 15. And of course, now with the x's, we have a factor of x, x squared, and x cubed. Right? 9x squared. Okay, well, the factors of 9 are 3 and 9. And x and x squared. 12x. Okay, 12 has quite a few, so we have 2, 3, 4, 6, 12, and just an x. Okay, so what's the greatest common factor just with the numbers? I believe that is 3. Okay, and the greatest common factor just having to do with the x would be, well, just the x. It's the biggest we can go that all three share. So therefore the greatest common factor is 3x. Okay? And 3x divides all three of these. They're getting a little bit more complicated, but, well, once you can do them, they're actually not that bad. So 15, again, 3, 5, 15. And then we have x, x squared, and then a y and a y squared. All of these are factors of 15x squared y squared. 10xy squared. Well, the factors of 10 are 2, 5, and 10. There's an x, a y, and a y squared. 50. Oh boy. Well, that's 2 times 25. And this is 5, 10, 25, 50. I think I'm going to run out of room here, but that's okay. X, and, ooh, y, y squared, y cubed, and I'll just squeeze this other one down here, y to the 4th. Okay, so looking at the numbers, the biggest one they all share is 5. Okay, for the x's, well, the biggest I can go is just x. There we go. And for the y's, the largest I can go for all of them, it's y squared. And there we go. So the GCF is 5x y squared. All right, now the last two, we're going to do, well, exactly the same thing, only I'm not going to list the factors anymore. I'm just going to do it, well, the eyeball method, just looking. So 15, 25, 30. All right, well, I can tell between those three numbers, the greatest common factor is 5. Okay, let's look at the x's. I have an x cubed, an x to the 6th, and an x squared. Okay, the largest factor of x containing that can be found in all three of these is just this one. It's the smallest. It's the x squared, right? So really, that's how quick they can be. Right. Oh, this one's kind of nasty. So let's look at the numbers: 14, 21, and 28. Okay. Well, I know 14 is not a factor of 21, so that's out. Yeah, it's 7. Okay, 7 is the biggest number that divides all three of these coefficients right here. Now let's look at the m squared, m to the 5th, m squared. So the biggest one shared by all of them is m squared. The n's, n squared. Okay, and if you want to list them out, okay, as I did with the other ones, that's totally fine. But eventually the goal is to be able to do them just by looking at them.